Okay, my friends, another shocker du jour. Anybody that's been following me understands what this is, and it is a tendon enthesis, which means an anchor, and that ball is a strap attached to a strap, which goes up to a muscle, and that's what pulls against that anchor. That anchor is locked into something. Now, this is also, I believe, one of these, and that's where the strap broke off. Just like it breaks off on here. I have some here. We're going to be looking at them in a microscope and some other things, and I think you'll find this quite interesting. Okay, I work with anatomists and sports injury people and so forth, and they focus in on these tendon entheses, and these are in joints and in muscles, anchors, and they tear. And they rip these balls out of here, and they are very painful injuries. Trust me, I've had them more than once. But these are really absolutely gigantic, even though they're tiny as can be. There's zillions of them, literally thousands of them in each one of these connections, as I will show you in a second. And they are tiny, 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 but that doesn't even start to be tiny when I show you what tiny is all about. Tiny is the ones that are in your skin and in your membranes, not in your bones and muscles. All right, remember now, these are the kind of tendon enthesis they're talking about. They have a strap, the strap runs down to a ball, the ball inserts in a bone or muscle somewhere, and that gives you something you can pull against with your muscles. Now, this is what all these little straps come from. Here's how many straps there are. You see these fibrils at the end? These are the ones that go into the balls. These little ones down here. You see how many there is? That comes out of one of these little fibers. One of these fibers comes out of one of these fibers. One of these fibers comes out of one of these fibers. This comes out of one of these. One of these comes out of one of those. You see what I'm talking about? You see how many fibers there is? Just in that one little one right here, there must be 20 of them or so. So you go 20 times 50 or whatever, times 1,000, times a million, times a bazillion. That's how many anchor balls you have. And want to see what the anchor balls look like? I'll show you. Okay, I know you've seen this, and I believe I'm going to be able to show you these features, and that ball is the same as what I have here in my microscope. Now, what we're looking at is the attachment spot right there. And I believe this is the artery that supplies blood. For everything needs blood, and then there's a vein that brings it back, and the veins clamp off. And that spot, I believe, is a vein, and I believe this is the artery. And you see how that turned into like a glassy looking substance? We're going to look at this very closely. But what I want you to do, if you really want to study mud fossils, get yourself a little manual like I showed you, and I'm going to be doing this actual classes. And what we're going to do is draw pictures of these things. What is this cavity here? What's going on with that? That looks like another cavity. What's this? And when we get down close, and we're going to look at this first dry and then wet, because you're going to see that, and then close up and far away. You got to get the lay of the land. You got to start with the full picture, which is what I'm doing here now. All right, then you go in and you home in on each little characteristic. Try to figure out what's going on. I know this is the wall that surrounds it, which is the same wall that surrounds that one, and it breaks right just like this. And I have another one here that I think I showed you, and I will show you again in a microscope. It broke the same way. They're all over the place. Those are the Moki marbles. They're the things that were on Hunstanton Beach in the United Kingdom. They're everywhere. So because every creature had them, just literally hundreds of thousands of them. And they always called them concretions. They're not concretions, they're tendon balls. And this is the one I have in the microscope right here. And I'm going to turn on the lights and show you what we're looking at. And then we'll keep looking through the microscope. All right, you have to keep the lights off to see it. What I'm looking at right now is that spot I just showed you. Is that spot. And there it is up in here. Now, again, you have to have the lights off to see it well. So that's what we're going to do. We're going to home in closer. I'm quite a ways off it now. We're going to get right down onto it and look at, you can actually see blood cells and everything else. It's very, very cool. And it's, as I showed you how many, literally millions, I'm sure there's millions of these in your body. These little fibrils, as I showed you, in the body, there's just hundreds of thousands of tendons, which is one of these. All right, and then coming out of that, just think of how many thousands of fibrils there are, and every one of them is attached to one of those black balls. It's just staggering, absolutely staggering. Look at this. And you get down to the bottom, here they are, the little black balls attached to the little straps. It's almost beyond the possibility of belief, but once you do the research and the work, if you can believe what's real, you have to believe this is real, because it's real. And we made other discoveries working with my friend Tyson out in Oregon. There's clamshells and things like that embedded in these creatures' bodies. Those were like bacteria. For these things, they were the filter feeders inside their bodies. That's why they're in the walls of these creatures' decayed bodies, because they were in their digestive system, they were in their membranes, they were in their white blood cells. They were actually doing the biological job that we have bacteria doing for us today. And I'm absolutely certain of it. I see it everywhere. And I have this stuff that shows the sizes are just beyond belief. And anytime you see the green, it means there's biology there, and something's feeding off that biology, and they'll do it all day long, forever. As a matter of fact, hold on one second. All right, you see that? Oh, I'm going to back this up here. All right, you see that? This is another one of the no-toes. You've seen the no-toe right there. This is another one. All right, that's a no-toe. Now, this one here, look, you see where the blood's coming out in the back? That's where the blood supply fed. It's still growing the same thing as on those today. It's been in my shop 10 years. It's another no-toe. Wherever there's blood, you're going to have this very green growth. And it doesn't take, they just grow. Okay, like I said, I have worked on this for many years. And I've been working with sports injury specialists from around the world. And these are the kind of things that cause your injuries, is because tendons rip or muscles rip. Now I'm going to show you, as I showed you how these tendons invest, I'm going to show you how they rip out of your body. This is how they rip out of your body on the flat tendon areas. This is where you get the pain. You see that ball? That's supposed to be locked in there. This happened to me the other day. I reached down to get a bag of bird food. My wife bought this 40-pound bags of bird food. And I reached down, I grabbed it, and I tried to lift it up, and I felt my back go snap. I felt a little thump. This is what happened, and it hurt like hell for 3-4 days. And that's what happens, is they pull out of these little sockets. Now, I have some here. Well, I have this one here that I cut. And what they do is they ride on top of each other. Basically like this. They ended up being on top of each other. I don't know exactly why. But this is the ball right here. That is that ball. And it's supposed to go through a finger trap. They call this a Chinese finger trap. And they go through, and the tendon can slide back and forth. It's got this much play. All right, and that's what they're supposed to have. It's just a little bit of play to give your muscles a chance to start to engage. And that's what these tendons do. They lock in. So this is one of those, and they slide on these surfaces. And then they anchor somewhere. And these little white fibers are the little white fibers that are in these balls. Now, let's just keep going. Okay, I'm going to try to make this simple. It's very complex, actually. That is a lymph node. That is nothing like what they show in the textbooks. This is so complicated, it's unbelievable. And that is, what it does is it's a dump for the body. Now, I'm just going to show you quickly how complicated the body is and all of these structures that nobody has ever seen before, really. All right, these are all the human organs that are all tied to your blood system. And what happens is they pump in and out enzymes. They secrete them into the blood. And it carries it around and it delivers it to the cells that need either that chemistry. Let me talk into the camera here a little bit. They carry these enzymes and these products that they produce in all of these different organs throughout the system. And they go into the blood. Now, this is the circulatory system and the lymphatic system. Lymph is what cleans the body out and cleans up the blood and all that. Now you always hear me talking about enzymes. That's all of the different organs that I just showed you create enzymes, basically. And hormones. Hormones are nothing more than exotic enzymes. Now, that is the pancreas right there. And you see all those little islands and so forth, those little cellular balls and so forth. Those are the islets of Langerhans and all kinds of different little names for them, but their primary function is to create enzymes. All right, I think I got something written here, hold on. Well, a lot of it is about mucus. Mucus is absolutely critical throughout your body. That's the slime that keeps all of the barriers lubricated, first of all, so they can move. Secondly, so that they don't get penetrated. In that mucus, all kind of bacteria lives. And the membranes protect the tissues. Anyway, that's a whole other issue. I just want you to know how complicated these things are and the kind of things that we're going to see from giant creatures that had giant things like this. And I can prove that they had them. There's no question whatsoever. This is factual. So when we look at things that nobody's understood before, they thought they were maybe starfishes or something. They might have been bacteria, literally. Okay, this is my claim that this right here is the same as that right here, only this broke off. And we're going to see the blood supply and so forth, and the tendon attachment, and all of the circular pattern that was left when that snapped off. And here it is, and it's going to be up on the microscope in a second. I have to turn the lights off. All right, you see this? I put a little moisture on it. It's just drying out. You see the brown, and then the white, and then the blue, and then the black vein, and then the artery, the red artery, and then this stuff here. This, again, is very interesting to me, that specific pattern. I'm not sure what to think about it, but it might just be at the attachment spot. I don't know. But this is like this cone-shaped thing, and it goes around. And then there's this pattern right here. Looks like a hot dog. All right, and that must have been filled with red blood. It looks like to me, because that's what happens is the red blood runs out, and then it fills in with silicates, and that's what you see there. So this is the same attachment spot that I showed you on that tendon. This right here is what they look like. This is a big shot of looking down at this one area. This is more focused. This is the membrane that protects this fluid-filled highway and these interstitium balls. Interstitium balls, this is more close up. Every one of those balls has a little tiny strap. And the strap keeps the ball anchored where it is so that you can move around and it'll gush and do this and that, but you come back to where that ball is anchored. That's obviously electron microscope shot. Nobody ever sees this detail. And as a matter of fact, they didn't even know this stuff existed until 2018. I'm not kidding you. This is Interstitium. All right, they did. They just found this. Just recently, 2018, meet your interstitium, a newfound organ. And this is the stuff that we're talking about. And this is that immune system part right here. This is what covers you. Your skin, your face, your hair, everything is this outer layer. And then once you get past that, this is supposed to keep you immune. And that's what we're going to be talking about, is all of these balls and interstitium down here. They just really figured this out only a couple of years ago. All right, so I just showed you, these are newly found organs. And this is like, there's just hundreds of thousands of them. And they all have these little straps going to them, the little black looking straps. And you could pull them and stretch them, and then they will come back to where they're supposed to be. All right. This is really going to be shocking, and I'm sorry. What it is what it is, and it is what it is. Now, this is mucosa, skin, membrane coating. It's literally a bilipid layer that separates you from your vital flesh, from whatever's out here, whether it's inside of your intestines or it's outside of your muscles or whatever it is. It's a membrane that coats one type of tissue from another, or from things that are flowing through your digestive system, your throat, your lungs, everything. Now, this is where you can't break through. If you break through here, this is when the layer I showed you down here, that really dark layer, that's the immune layer. That's where your white blood cells live. Up here is where that interstitium is. All these balls, they stretch around and you do all this. This is real gummy, the pink stuff. And it just flops all around. And it's filled with fluid. And then these brown straps are the ones I showed you in that bigger shot where it showed all of the biology way down. Those little straps were these brown ones. And they held onto the balls. And the balls are like stapled almost. Think of it that way. So everything else can stretch. You could pull this, and this bag will go flat as a pancake, but it'll come back because these brown ones are like springs, if that makes sense to you. And it goes deep. The tissue runs both ways, everywhere. So you got the layer on the top, you got the mucosa here. Now, as I said, this is going to be shocking because, as I tell you, the things on Earth, as I showed you, this is a hairball root. Hundreds and hundreds of times bigger than a normal human. This is one of those tendon balls that I showed you in those pictures, and this is one of those balls. And they get bigger than that, much bigger. Because watch how big these get. That's how big they get. That's the mucosa. And that, I believe, is skin. When you get into these kaolin clays and chalks, that's the real fine facial skin. It's a real thin skin. On your hands and your feet and so forth, your fingers, very different skin. But then you get down to this layer, which I showed you, which is the interstitium layer, which has all the balls running through it and all of that fluid-filled bags. Those just dump right out and they turn into mud because they got blood in them and they got all that kind of stuff. It's gooey sort of stuff, but it's mostly watery and it just runs right out and the balls go down. These balls are tough and tougher, but they have biology built into them. That's why you see all this stuff growing on there. That stuff is growing on there, and what it's doing is it's eating the biology, and I can prove that too. So don't forget, there's your mucosa, there's your interstitium, there's the red, fleshy, gooey, fluid-filled bags that have dropped down. This is the mud that is the eroded part, These do not erode because they think they're concretions. They're tendon balls. So don't forget, here it is right up at the top, here it is. That's what we're looking at. Now, let's step back and check things out a little deeper. All right, this is something, 12 mysteries that scientists still can't explain. I'm not sure where this is from. But remember I said they grow like crazy? You see all these green things? Anything that has blood in it, anything that has biology in it that's still, viable, green stuff grows on it like crazy. It loves blood. All of these were tendon balls. So every one of these had a strap. And you say, oh, that's impossible, Roger. He goes, no, it's not impossible. There was even more of them than this. There's still batches of them underneath this. This is just what's up on the surface. They're deep. They're everywhere in here. They're piles of them on top of piles of these. You want to see? Let me tell you something. This is the tendon. And you have literally thousands and thousands and thousands, I don't know how many thousands, but you have many, many, many thousands of these in your body. And they come down to these fibrils, as I showed you. And every one of these fibrils is attached to a ball at the very end of it. And I'll show you this in a microscope. I'll show you the attachment. I'll show you the biology. And here's what it is when they go into the earth. Remember these bundles? They come down from one bundle to the next bundle. Here they are right here. That's the biology of it right there, the geometry of it. Let's go with that. You see them? You see the bundles? These are these bundles. And every one of these ends up going to a tendon ball, which is one of these. And I'm going to show you this in the microscope. And I can literally prove what I'm saying very, very simply. All right, I know I showed you all of these little tiny fibrils, and every one of them goes to a tendon ball. And the tendon balls are these little tiny, tiny, tiny little things that are in the skin and so forth. And what else did, and I showed you how they are edible. They turn green, and they're everywhere. And on Earth, they call them the Moki marbles. I didn't show you this. On Earth, these are the ones that are in the skin, called the Moki marbles. They're all over the place. They call them concretions. They're the same as these, only these are bigger. Basically, that's it. And that's what they look like way, 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 way down inside of that tissue right there. All right, so now let's go a little deeper. All right, what I'm going to show you is two things. This is the tendon anchors we're talking about, these anchor balls. They have fibers running into them, and they are also supplied with some kind of nutrients. This is one right here, which I will show you, and it's going to be unbelievable hard to dismiss. I can show you the actual attachment, exactly like they're showing here. All right, this is another tendon ball right here. This is where it attached right there. All right, that was the spot that attached. Now, on the other side, remember how they wrap down and the other ones wrap down? And this is the kind of stuff they're talking about on these other unexplained balls. I can't remember what you name them, what the name of them is, but they have these kind of little pinchy things underneath and the bottom, which this does too. And then, of course, it has the attachment at the top where, when I put a little water on it, you'll be able to see it very easily. This is what it is. And when you see this one, there's no possible way of mistaking it. And it tells me a lot about the structure. And you'll see it in a second in a microscope. Now, this is about as deep as you can get into biology and geology and history and the ancient texts and everything. It's 100% wraps up into everything. So this is not just one little thing like a rock can turn into, a bone can turn into a rock, or a tendon can turn into a rock. No, this is our literally everything. Literally everything. So let me show you the microscopic stuff for this. This is fun. Check this out. It still blows my mind every day. And how it can be just ignored is more of a mind blower than it actually being real. All right, so let's start out with what am I going to show you in the microscope. I suppose we're going to be looking at this brown looking stuff, because they would call this a concretion. It's just absolutely, somehow it all formed into a ball. Well, I'm also going to show you this black spot. And anybody that understands mud fossils knows black is vein blood. I'm going to show you that spot right there, which is this spot right here. All right, the rest of this stuff is the anchor ball. That's this spot right here. Snap, snapped right off. When you see it in the microscope, you'll see it. Now, I always start off by doing them dry, and we look at it dry, and then I'll make it wet, because that makes a whole huge difference in what you see between dry and wet. Now, again, this is going to be critical to look at. That's the attachment. And you'll see where it's fed with blood and everything else. And this is vein blood leaked out of here. I don't know whether it was fractured and leaked out. I believe that's the case. But we'll take a look at it and see if we can determine that. All right, we're all doing the research together now, my friends. So that is this. In a microscope, she's going to be in a minute. Now, what about this? Same case here. We're going to look at where it embedded itself and where it snapped off, and then these things down here. All right, so let's start with this one. This one here, very, very simple to see. All right, let me get it set up. Before we go to the microscope, I want you to understand, every single tendon in your body, I mean, there is literally hundreds of thousands of them in your body, is anchored with these balls. And not just one ball, there's a whole ton of them on each one of these fibers. You see all these different fibers? You see all these? This is just stunning. It's stunning, the amount of fabric that's on our bodies. And every bit of that fabric has to be invested and embedded somewhere so that your red blood vessel, your red muscles can pull against it. Otherwise you can't do any work. And what good are you if you can't do any work? We were made to work, my friends. I got to tell you, it seems that way. Oh, by the way, there's this line that runs down the center of your body. It's called the linea alba. I couldn't think of the name of it. For some reason, I just couldn't remember it. And that is the center line, and you see it in the women in their female parts that actually cracks open, and I will show you that. Now, here's why that line forms. It's also called the hunter's line. Now, when you are first conceived, the cells, you know, it's a sperm and an egg, and it starts to become bigger and bigger and bigger as cells divide. All right, and so it goes to 2 cells and 4 and 8 and 16, 32, and I believe it's 64. And when it hits 64 little cells, it goes bloop, just like that. The inside goes like that, and the outside comes together. Bloop, and it makes a seam. So now you have a cavity inside. That's your abdominal cavity, which is here. And then outside, this is where it seams together. And that's where it cracks open. Let me show you that, and then we'll go. We just keep going through this. It's going to turn into a bit of a ramble, but that's the way you learn. That's the way I learn. Oh, remember I talked to you about the hunter's line? I'm going to show some female body parts here, but I have to prove my point. The hunter's line was where the blastula comes around and fuses, and then inside is your abdominal cavity. Well, this shows exactly where the hunter's line is, right there. That is the line, that little tiny split right there. That's what fuses your body together. When you get petrified in this particular manner, it's split along that line, the linea alba. Now this, I believe, is a coffin birth, and this is the fetus baby arm shoulder right up here. And there's his face. You see his mouth, his nose, where his eye is. And this is tissue ripping here. You see this is tissue ripping? That means he's being forced out the wall of the vagina. See how it's supposed to be like this? These are the vaginal ripples. That's normal. That's the Hunter's line, the linea alba. That's a coffin birth. Almost certain of it. And anyway, that's the Tracian womb cave, they call it. And that's exactly what it is. It's a womb and it's a cave. Now, as I showed you, all the giganticness of what we're looking at is just gigantic. And the number of interstitium balls, nobody in their right mind would ever have suspected. They are just everywhere. And there is, and because these creatures were so absolutely enormous. And I mean, as you can see, where was it? Oh, okay, Huntington Beach, right there. I mean, if you can't see how big these creatures were, this is the interstitium, and I don't know how anybody could dismiss that. There is no way to dismiss it other than to just say, I don't want to see it, don't talk to me about it. All right, now, what about the muscle fibers? This is what skeletal muscle looks like, and that's in a mud fossil, and this is where blood works its way into the muscles to give them energy. And this is what actual muscles look like. Hold on. Where are my muscles? All right, well, these are sarcomeres. Remember, these are sarcomeres. And here's what sarcomeres look like right here. There they are right there. Same thing. Identical. No difference whatsoever. Absolutely 100% identical. And these are living ones from a living creature, or probably an autopsy. This is what they look like as these two muscle fibers pull in and out. They can come in like that, or they can come out. These are relaxed. When they come together, you just get a dark spot. The whole thing comes together like down to here and to here, and it's just dark. That's how your muscles work. They're called sarcomeres. There they are right there. All right, and when they erode on Earth, they crack down these lines right here. And these, they're on Mars too. They're on Mars. I don't care what anybody says. They're there. They call them the Mars crab. Is an artery that feeds this. We have so much to learn about everything, and I mean literally everything. Now look at this. You've seen all of these balls and these tendons and so forth. Well, they come to a certain spot sometimes, like a shoulder or whatnot. But you see these little seams? That's what they call slurpy. Slurpy means small, leucine-rich proteins. What does that mean? They're slippery. They're slimy. These things have to move in very, very fluid. And as a matter of fact, look at this. This is what's called synovial fluid. Synovial. It's a membrane sinus thing. Listen to this. Coefficient of frictions. That means how much scrub you have, something against another thing. Synovial joints are the least friction of anything there is that exists, and it's so much more friction friendly, it's unbelievable. Can you read that? Just look at the coefficient of friction. You see how much synovial joints are down here? There's almost no friction at all. Almost nothing. So, but the key is that you have to keep your synovial joints fluid motion. You got to keep them moving, otherwise they'll lock up. and they'll actually literally glue together. And I can prove this as well, because I worked with one of the top guys in fascia in the world. He was the only guy that knew anything about it 10 years ago, because when I found him in the Mudfossils, I said, what the heck is this? I knew it was part of biology. And we started talking, and they used to call it fuzz, because it would coat things, and then you just cut it out and throw it away. He said it was just like cushion, didn't mean anything. I said, no, this stuff's got a major job. But they never saw this before. And they just found it 2018. They started to realize, yes, this is real stuff. Let's start looking at it. And they did, and they realized it's way more important than they ever thought, because it houses your immune system. Whole nother story. But look at what this does. These are tendons. This is going to a shoulder or something. These are the fibers. Remember I showed you how they lock in? This is locking in one spot. And other things in the body lock in, like in your fingertips. This is what's called an apical tuft. This would be sitting somewhere like this if it was a fingertip. And running out of every one of these little cavities, even that one right there, is a ball that had a strap. And every one of those balls ran down like this to wherever it was attaching to. In the finger, it runs down to the joint of your finger. And that's the apical tuft. It sits right on the tip of your finger. And all those balls, just like that one, attached into these holes. And they're all gone now. See that? That's the apical tuft. That's this right here. You see that little split right in it? That's it. And all of these balls lock in there, and that's why your finger can do all these different things, because these run down to the tendons. I'm deep into this stuff. Alright, again, this is absolutely shocking, but it's true. That is the mudfossil muscle. Alright, let's look at it one more time. That's blood. That's servicing these fibers so that they can do their job. When it died, it just died, and the blood turned into hematite, which is the red blood, and this is the membrane layer. It's at the top over here. And here it is in actual true body tissue. You don't see the red blood or anything in there. Maybe they drain the blood. I don't know. But there's no blood on these, so we missed that in what it should be. You should be able to see blood in here, which we did. Now, you can see the banding and everything. That's all, yeah, exactly. We saw the exact same thing in the mud fossil. The banding, all of that stuff, identical. We can see some shifting. We can see some skin pulling the banding this way. It will come back. There's separation in these layers, which you didn't see really in that other, they need to be separated in a certain number of layers. It looks like 2 or 3 or 4 layers in between, and then they get more blood. So we saw the sarcomeres here, and we saw how they contract and how they just relax. And we see how they can shift. Yes, I agree with all this stuff so far. All right, are we in agreement so far? You saw what I just showed you in the composition. We saw this, we saw that, we saw this, we saw this. Now, what I want you to see is how unbelievably tiny these blocks are. This is electron microscope of muscle fibers. Dig in close. Get way down there and look at what you see making up the blocks of those fibers. You see this? That's what makes up the blocks of muscle fibers. That's why they can contract. Those are the sarcomeres. That's how tiny they are. Again, electron microscope shot of the sarcomeres. Now I'm going to tell you this, as I explained the other day. The earthquake in Turkey that just happened, where everything collapsed, there was a big red blood area that ran out, and then the sarcomeres collapsed, these blocks. Let me explain one more time I can show it very simply now. Okay, if you see in my other video about it, here's what happened. There was a layer of blood like this underneath the sarcomeres, which are the blocks that fell down. They can be easily seen, and I showed them very clearly. You can see them on all these blockiness. This ran out down the hill. It left a cavity underneath. It just collapsed. That's what happened in Turkey. Okay, my friends, this is it. This is ITV News. And this is, they're pointing out this collapse of this whole mountain collapse here. These are the sarcomeres. And these are the blocks. They're actually blocks. What happened was the center was where that blood was. It ran out down here, which eventually it created a cavity and it just collapsed. That's what happened here. All right, it shows. All right, here they are right here. These are the sarcomeres. You see? Boom, 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 boom. They broke right down. These, you see how flat they are? These are the sarcomeres. Now I'm going to let it play as they go with their drone, and I'll stop it if it becomes appropriate. Here we go.
To the bottom of it for the perspective from down there, but actually the best way to illustrate what we're talking about here.
All right, it's appropriate. This was underneath this, down underneath was that layer of blood that supported these sarcomeres when this creature was alive. And I don't care what you say, this was a creature, and this is the creature's skin, literally. And underneath that is the muscle layer. And that's where these blocks, there's actually just squared off blocks, and they're lined off just like I showed you on the other one.
Is from above.
You watch all the stripes and the lines, and then you're going to see black and red. I believe this right down here, if they were down there and look close, I bet you they're going to find that that's hematite. And that's what's underneath these blocky layers.
The local people said that at the time they thought it.
I believe these are, you can see the blocks. It is what it is. Now, I'm almost 100% sure if they look down in there, they're going to find hematite and magnetite, which is the red and the black blood. And again, I see this is an artery.
It was an air raid. The sound of explosions
this is all arteries
created by cracking rock. The flashes by the sparks.
Artery, vein.
Reported for days now, destroyed.
Hold on one second. Let me come back to where I was. All right, don't forget now. Anytime you see red or black, that's vein blood or artery blood.
Said that at the time they thought it was an air raid. The sound of explosions.
You see the red on there? That's a sarcomere.
Created by cracking rock. The flashes by the sparks that flew.
I believe this is artery blood. I mean vein blood, which is black. And down here you have the artery blood, which might be pouring out of here. But anyway, it ran down this hill and out. And that's why these trees are growing so well right here, because artery blood makes things grow very, very well.
As the Earth's crust was torn apart.
No, it just dropped. You see how all this stuff runs downhill? You see how these things are growing like crazy compared to everything else? Blood makes things grow absolutely insanely green. You see it running out of here?
Yep.
I mean, it's a tragedy. It's absolutely terrible, but it's a cavity under the ground, and it's because we've taken all the moisture basically out of the ground, and now we have these cavities. And there's a lot of places sinkholes are collapsing all around the world. So how do you deal with this? You have to understand to look for the signs of where there might be an outflow of bodily fluids, because this is a body of a creature. Absolutely no question about it. All right, think about this now. These trees were up here. They just dropped. The whole thing just dropped. There was a cavity under there. It didn't get ripped. It didn't get torn. It just dropped. So what had to have happened? underneath all of these sarcomeres, which I showed you, these stripes and all these little layers and all these little blocks are sarcomeres. Underneath that was that layer of red blood that ran down this hill. It ran out and down the hill and created very good growing conditions, I guarantee you, below this particular outpouring spot. There's no question they would grow much better there than anywhere else, because green grows, I think things grow very green in the blood. Shown it a million times. And they sell blood meal for that specific purpose, to make things grow green. And that's what happened here. It ran out, as I showed you before. Don't forget, sarcomeres right there. Sarcomeres right there. Blood right here, ran right out down the hill. To me, I see no other possibility here. These were the sarcomeres. You see them in the walls. Something made the stuff leave, which is red blood just run right out. I can make mud. It turns into mud. It turns into literally liquid, muddy mud, and then turns into, when it dries up, it turns into clay and so forth. That is what blood does. And that, my friends, is what blood was underneath this. So, what does that tell you? If that creature was that big, there's going to be a lot more places like this. What you have to do is to look and to see what was the characteristics where this particular event occurred. Whoops. Which means, can I find a place where there's red blood running out that is making things grow well? And if you see that, you can be pretty assured that it's taken some blood out from somewhere that was feeding bodily tissue. Core samples could tell you probably where you are in the body of the creature. What, you know, if you find sarcomeres, you're in the muscle. I mean, it's so overwhelming now that everything has to be started from new again. I mean, literally started completely over again in geology, in ancient history, in biology even. A lot of this stuff wasn't understood because now we can see it. I mean, we can see it, like unbelievably see it. And as you see right here, we can see so many things now that are not visible to the naked eye. And even like this right here. You see that? You see this white and this green as green can be? Why? I know why. This right here is from red blood. You see the red blood? This, the white, is from black blood, which is the vein blood. This is from artery blood, that's from vein blood. It just happens to be they're sitting right next to each other in such a wet area that there's so much biology growing, you can quite easily see it. Now, I showed you about the hunter's line. Now, here's where my sarcomeres break off. You see right there, these are broken. All right, I'm going to just let it dry out as we watch it. Now, what are we seeing here? That, I believe, is the artery. You see the red? That's artery. Black is vein. This is where it was feeding this, and I've seen this on many other places, and I think I'll be able to show you some more today. This little area here is, for some reason, runs right down along with the strap. And then the strap is here, and that's the anchor. Now, let's look down at this really close up front. Because I can't give you much more detail than what we're looking at here. But don't forget, we won't be able to see this one here and this one anymore. But those are the blood supplies, the vein and the artery. The vein's always black, the artery's always red. Arteries, they cavitize, they create cavities because they run out very easy. The red blood, it just runs right out. The black, different story, totally hard. Magnetite, hematite, totally different story. Now, I'm going to home in real close and then I'll come back. All right, I'm going to just scope around here, and you're going to just have to follow me. Now, remember I showed you where the artery was? There's the artery right there. All right, that's the cavity that the artery comes up through. And the artery runs down, and it comes in through the side. And here's, remember I showed you those little opal-looking things, those little bubble? There's that right there. This whole area here, for some reason, it's different. And then it starts to create this wall. That's the wall. And it circles all the way around to the other side of this crystal stuff. And here's the other side of the crystal stuff. And that's where the wall is there. Comes right up to the crystal stuff. And that's the wall going all the way around, all the way around, all the way all the way around, all the way around, around, and there, bang, to the other side where the crystal stuff is. Now, in the middle, what do we have here? These are all the straps that are, you know, we're locked in here. This is all floppy. I'm sorry, I can't lock it in solid. Let me back it up a bit so you can see it in a little more perspective. Hold on. All right, maybe that's a little better. There's the whole thing at once. That's the vein. This is the whole lockdown. This spot here, this is very interesting to me. As I see that, I've seen that many times. And then this side is where the artery came in. And the center is obviously where it locked in place. And that's this tendon wall right here. That's what we were just looking at in the microscope, right there, that spot. Now, it also has a black spot. Let's take a look at the black spot, because that will be vein blood. And I believe it's from a crack, but it could be from a regular blood vessel, but I don't think so. Hold on. No, I'm right. It's a crack. There's a crack. There's red and black together. And here it is right here. Right? There's a crack. You see it? And this is bone black, they call it. So that bone particle cracked, which is not really a bone, it's a tendon wall. But you see this brown looking stuff? That is what the tendon ball is like. Let me see if I can find it. This is what tendon balls look like. This one's all fractured up and broken up. But some of them have just that sort of a surface, like you see it over here. Nice smooth surface. All the rest is stuff that's biology that's attached to it that just didn't break off. And they call them concretions. I can go along with that. You could say that's a concretion because that's not the same stuff as this stuff. So they'd have to think, yeah, well, that stuff glued to that stuff. That's what they call concrete. And that would be a concretion. So I can go along with concretion, but it's from a biological creature, you know, that has different layers of tissue on it. And that's a crack in that, that's a fracture zone that caused that black to come out of there.